students of class 12. Now we are today switching over to the new chapter and explaining example 3.1. In this example, it is being asked that you have to estimate the average drift speed of conducting electrons in conduction electrons in copper wire whose cross-sectional area is given and is carrying a current of 1.5 ampere. We have assumed that each copper atom contributes roughly one conduction electron, means one electron is free to move from one place to another, delivered from each atom. So that way is the density, and density of copper is also given, then and its atomic mass and atomic mass unit is also given. Then we have to compare the drift speed obtained with the thermal speed of copper atoms at ordinary temperature, the speed of propagation of electric field along the conductor which causes the drift motion. So that means we have to before we solve the latter part, we have to look into to find the drift velocity, and for that we need to find the charge per unit volume, free electrons per unit volume available, and then we have the direction of drift velocity of conduction electron is always opposite to the direction of electric field, because we always consider that the electric field is such that which pushes positive particle in that direction of electric field. So electrons move against the electric field. Now we have the relation for drift velocity Vd is equal to I by NEA, because we have I is equal to NEA Vd, and since it is given the charge on electron, cross-sectional area of the conductor is already given 1 into 10 power minus 7 meter square, and current is known to us 1.5 ampere. Therefore the density we have to only find the density of electrons per unit volume, and since there are how many atoms are there we can find, and that number of electron will be there present in its volume. So we have the total number of charge present per unit volume equal to total number of atoms present in each mole, and then that divided by the mass of the each atom, and then multiply it by the total mass of the conductor, and therefore we get charge density. You see, density of copper is given, so we have that multiplied by density gives us the total charge density, and that becomes equal to 8.5 into 10 power 28 per meter cube. Now given this value of n, we get the drift velocity I divided by NEA is equal to 1.5 divided by 8.5 10 power 28, that is the value of n, and A is the cross-sectional area, and the E is the electronic charge on it, 1.6 10 power minus 19, and the cross-sectional area of the conductor is given, that is 1 into 10 power minus 7 meter cube. So that way we get the drift velocity equal to 1.1 mm per second, means the electrons are moving under the influence of electric field at a speed of 1.1 mm per second, that is few millimeters per second. Now when we want to find the thermal speed of copper atom due to the temperature it is having, then you see that the vibrational speed of copper atom is about 2 into 10 power 2 meter per second. So that means at 300 degree Kelvin we can find the typical vibrational motion is equal to under root thermal speed is equal to under root kb into T by m, where what is kb? kb is the Boltzmann's constant, T is the absolute temperature of the material, and mass m is the mass. So that way it becomes to be 2 into 10 power 2 meter per second, which is much greater than the drift velocity of electrons due to electric field applied across the conductor. The electric field traveling along the conductor has a speed of electromagnetic wave, and it is in equal to 3 into 10 power 8 meter per second approximately. And the drift speed is in comparison extremely smaller by a factor of 10 power minus 11 with respect to the thermal speed of the particle. Now let us look at another example 3.3. This example is quite simpler one, that when an electric toaster is uses nichrome for its heating element. That means the wire is made of nichrome element, and which is having when a negligible small current passes through it, its resistance at room temperature is 27 at room temperature 27 degree is found to be 75.3 ohm. When the toaster is connected to a 230 supply volt, the current settles after a few seconds to a steady value of 2.68 ampere. Now we have to find what is the steady temperature of nichrome element, and the temperature coefficient of the resistance of nichrome is averaged over the temperature range involved is 1.7 into 10 power minus 4 degree per degree Celsius. So for finding the average temperature, we have to find the resistance. The resistance at given temperature R is found to be we use the relation V is equal to U plus AT, V is equal to IR, and then from that we have R is equal to V by I, and that is 230 volt is applied, and the current flowing through it, the steady current flowing through it is 2.68 ampere as given, and therefore we get the resistance of the coil. Now using this relation, we have the relation RT, that is final resistance, is equal to initial resistance within bracket 1 plus alpha change in temperature. Now where alpha is the temperature coefficient, and that is given to us, it is 1.7 into 10 power minus 4 per degree Celsius. So we get change in temperature equal to we get the change in temperature equal to already we know it, that the temperature is change in temperature is equal to R2 minus R1 and divided by R1 into alpha. And then we find that since we have R2 is equal to R1 within bracket 1 plus alpha T2 minus T1, therefore we have change in temperature, that is T2 minus T1 is equal to R2 minus R1 divided by alpha R1. Since we know the value of R1 given to us, that is at 27 degree, and then we have the change in temperature T2 minus T1 is equal to 820 degrees Celsius. Now since the temperature, therefore the temperature T2 will be equal to 820 plus T1, and T1 is 27 degrees Celsius, so that becomes 847 degrees Celsius is the temperature, a steady temperature of the element of the coil. Now we again have another example. the resistance of platinum wire of a platinum resistance thermometer at ice temperature is, ice point is 5 ohm and at steam point is 5.23 ohm. When the thermometer is inserted in a hot bath, the resistance of the platinum wire is 5.795 ohm. We have to calculate the temperature of the hot bath. Now we have the relation